Welcome to question 3 of the 2016 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 3 we have let the function f, which has a domain of all real numbers excluding 1, map to the real number set where the rule f of x equals 2 plus 3 divided by x take 1 describes the function. So for part A we need to sketch the graph of f, and we need to label axial intercepts with their coordinates and label any asymptotes with an equation. So the first thing that's important in this type of question is to work out what type of graph we're actually dealing with. And because we have a 1 over x type situation, we know that this graph is in fact a hyperbola. And if we are dealing with a hyperbola, this plus 2 constant out here and the x subtract 1 on the bottom line gives us important information about our asymptotes. So the plus 2 gives an asymptote at y equals 2, which we're now going to draw in with a dotted line at y equals 2 on the grid. And as the instructions said, we need to label that with an equation, which is y equals 2. And now x subtract 1 gives us an asymptote at x equals positive 1, because the denominator cannot equal 0. And again we need to label that as x equals 1, which is its equation. Next we need to find key features such as the y and x intercepts of this graph. So first of all, the y-intercept can be found by letting x equals 0 in our equation. So that means that f of 0 is going to equal, we're going to have 2 plus 3 divided by, and wherever there's an x we're going to put 0, so we're going to have 0 subtract 1 on the bottom line, and that is going to give us 2 subtract 3, which is negative 1. So that gives us this y-intercept here that is at 0, negative 1. And next we're going to find the x-intercept, and to do that we let y equals 0 in our equation and solve for x. So that will give us the equation 0 is equal to 2 plus 3 divided by x subtract 1. And now to solve this equation we're going to start by subtracting the 2 away from both sides of the equation. So we find negative 2 is equal to 3 divided by x subtract 1. And now we're going to multiply by whatever's in the denominator down here, which is x subtract 1. So we find that negative 2 times x subtract 1 in brackets is equal to 3. And then we're going to divide by negative 2, so we get x subtract 1 is equal to negative 3 over 2. And then adding 1 to both sides we'll get x by itself, so we get x equals negative 1/2 or negative 0.5. So that gives us an x-intercept just here. Now to be accurate with our graph, because they have provided a grid, we're going to substitute some more values of x in to find their y values. So to choose these values we're going to choose numbers like 2 and 4, which are values that are on the grid. And on the other side we might choose things like negative 4 and maybe even x is a half, just to get a feel for where the graph goes. So if we start with f of 4, so that's the function when x is 4. So x is 4 in this position on the grid, and we're going to find the y value of the function now. This is going to equal 2 plus 3 divided by, and wherever there's an x we're going to put 4, so 4 subtract 1. And that gives 2 plus 3 divided by 3, which is 2 plus 1, is equal to 3. So this gives a little point here, and I'm not going to draw it as a massive point because we don't have an endpoint here, the graph would continue, but that's where the graph's going to leave this grid. If we do a similar thing at f of 2, which is just another convenient point on our grid, we get 2 plus 3 over 2 subtract 1, and that is going to equal 2 plus 3 over 1 is 3, which gives 5. And now that's enough information to draw the top part of our hyperbola, so it's going to look something like this, and it continues in both directions. And now if we just find a few more points on the other side, we'll have a really accurate graph. And again, you want to do this as quickly as possible, just so that you get an accurate graph but you don't spend too long on this question. So we're going to put in the value of f of a half. So that's going to find where we are at this point on the grid. And if we do calculate that, we get 2 plus 3 divided by a half subtract 1, which is equal to 2 And this is actually going to be 3 divided by half is minus 6. So we're going to have 2 minus 6 is minus 4. So that means the graph will pass through this point just down here. And the last value that I'm going to find, just to make this a really accurate graph, and in fact it's probably a bit of an overkill at this stage, is when x is minus 4. So that will give our coordinate over here at negative 4. And that's just going to be where the hyperbola leaves the grid on the negative side of the x-axis. So in our rule we'll have 2 plus 3 divided by negative 4 subtract 1, which is going to be 2 subtract 3 on 5, which is going to equal 7 on 5, or about 1.4. So that's going to be a value just here. And again, it's not an endpoint, it's just where it's going to leave the grid. So our hyperbola is going to look something like this. It's going to pass through all those points that we just found, and now we have a really accurate graph of f of x. The last thing that I perhaps should have done when I put the points on is just give the coordinates of these axial intercepts. So the x-intercept was negative 0.5, 0, and the y-intercept, which is just here, was at 0, negative 1. So that is the completed graph for part A. So from the examiner's report we can see that 57% of students received full marks and another 24% of students received 2 out of 3. So overall it was a well done question on this exam, and the examiner stated that some well constructed graphs were presented by students. The highest scoring graphs were clearly labelled with correct points and equations as specified by the question, and that care was taken in showing the asymptotic behaviour and nature of the curve as it approached the asymptotes. Using a dashed line to represent an asymptote indicated that the curve f was distinct from its asymptote. So they're just a few really good reminders on how to sketch graphs. So for part B of question 3 we're asked to find the area enclosed by the graph of f and the lines x equals 2 and x equals 4 and the x-axis. So I've got a computer to re-sketch the graph that we did by hand before, and this is the line x equals 2, this is the line x equals 4, this is the x-axis, and obviously it's bounded by that curve, so we're looking for this area just in here. And we know that area is related to integration, so that the area that we are interested in is equal to the integral between 2 and 4, so the upper and lower bounds, for the function f of x, which is 2 plus 3 divided by x take 1 dx. And now we need to find the antiderivative of 2 plus 3 divided by x take 1. And the antiderivative of 2 is simply 2x. And the antiderivative of 3 divided by x take 1 actually results in a log expression. So it's going to be plus 3 times log e of x subtract 1. And you can use your formula sheet to help remind you of what the antiderivative of a function like that is. Again, we're going to have the terminals 2 and 4, and now we're going to sub in the upper terminal and subtract away the lower terminal substituted in. So this area is going to equal, and substituting in the upper terminal of 4 is going to give us 2 times 4, which is the 2x, plus 3 times log e, and we're going to have 4 subtract 1 in the brackets, and then we're going to subtract away the antiderivative with the lower bound of 2 substituted in. So we're going to have 2 times 2 in there, we're going to have plus 3 log e, and inside here we'll have 2 subtract 1. And now we just need to simplify this, so this is going to equal 2 times 4 is 8, plus 3 log e, and 4 subtract 1 is 3. And then over here we're going to have subtract 4 and subtract 3 log e of 2 subtract 1, which is 1. However, log e of 1 is simply 0, so that's going to give 3 times 0, so we don't have to worry about that term now, it's simply 0 overall. And our answer is going to be 8 subtract 4 is 4, plus 3 log e of 3, and that's units squared because we've found an area. So that is the answer to part B of this question. So from the examiner's report, we can see that a lot of students progressed on this question, with 46% of students getting full marks and another 30% of students getting 1 mark. So the examiners went on to say that many students were able to identify the required integral that would give the area. However, many students made an error in evaluating the terminals. A common error occurred as a result of incorrectly applying the logarithmic laws, and that often gave an incorrect answer of 4 plus log e of 9. Many students were unable to recognise the antiderivative of the reciprocal of 1 on x, which we talked about resulting in a logarithmic function. As with previous examiners' reports, they've also pointed out that the dx was often missing, and that's from the original setup in the integral up here.